The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Welcome to another edition of the Seven Signal Webinar Best Practices series. We're going to get going here in about 2 or 3 minutes. I've got 10:58 here local time at the Seven Signal headquarters, just south of Cleveland in Independence, Ohio. And Dave Hallis is with me today. Dave hasn't been with us in a few weeks, I guess. Dave, good morning to you.
Good morning to you.
And you are southeast of the city of Cleveland as well, and you're by Kent State, is that right?
That's right. I'm in beautiful Brimfield, which is right next to Kent State.
All right. We'd love to hear from all of you, just as we do each week. If you don't mind using the Q&A panel to let me know, or let Dave and I know where you're dialing in from. We love hearing from all of you, and would love to know the city and if you're working from home or the office. As many of you guys know, I've started to make my way back to the office 2 times a week, which is on par with some of the other folks here at the headquarters as well. So we kind of varies between 1 and 3 days a week. Certainly no one's back full-time yet here at the office. And to some extent, I don't think we expect that. So I'm kind of curious where everyone's coming in from. Let's see, Andrew in Chicago. Andrew, let me know if you're working from home or remote, if you don't mind. It looks like Daniel is working from home in Rochester. Hello from South Africa with Abu. Thanks for joining us today. So far, you're taking the prize for distance. We got Lewistown, Montana, and oh my gosh, Dave, I got to put my glasses on.
Already got mine on.
Man, when I hit 40, that my reading just went downhill. So Lewistown, Montana, smack dab in the middle of Montana, right on, gorgeous. So I assume that means you're working from home, Rochelle. Abo is definitely working from home. Tom from Macon, Georgia, welcome, Tom. Dave is working from home in Hillsboro, Oregon. David, welcome back. And Andrew says he is working from home. Thanks, folks, for letting us know where you're dialing in from. Keep those coming, and as we get lags, I'll continue to update folks on who else is logging in. Welcome, Glenn from Belgium. Wonderful. Thanks for joining us again, Glenn. Good to see you. We're going to go ahead and get started. We've got a great topic for you. We're going to talk about channel utilization today and get back to the basics a little bit. We go back and forth with topics for our webinars, and we go to general industry type topics and very technical topics, and this will get into some the technical aspects of Wi-Fi, and specifically around channel utilization. We call this channel utilization 101, and Dave Hallis is going to help us with that today. Dave's one of our solutions engineers at CWNA and chaired a lot of interesting task groups, and he's going to talk a little bit about that before he gets going, so you can get a better understanding of why we should listen to Dave. We love Dave over at Seven Signal. We're lucky to have him. So just a couple quick updates before we get going. For those of you who join us each week, you will not be surprised by this first one. We do not get into any product discussions on our Wednesday webinars. We do have our product tour for that each Friday at noon. So if you do want to see a product tour, go to go.sevensignal.com/tour, and we'll get you registered for that. Eric Camuli and I do those product tours on Fridays. They're a lot of fun. We will share today's recording with you all. We can share the slides with you if you're interested in those. And we do post all of our webinars to YouTube. So if you're getting antsy and you haven't gotten the recording from me in about an hour, you can go to YouTube and get a copy of today's webinar and share that if you'd like. We also have a virtual user group coming up at the end of June that you're all invited to, not just customers, though customers have a nice incentive for joining us, and I'll get into that in a second. We do have some special offers for our Mobileye product that I'll share with you. It's a 50-450 offer that we've got for all of our prospective customers. And as always, our webinar series is CWNP certified. So for those of you who are looking for CWNP credits for your CWNA or CWNE, CWS, you can use these for those continuing education credits as well. So I mentioned our virtual user group, or VUG. If you are interested in joining us for that, you will get an email on that as well, inviting you. But if you're getting antsy and you want to hit that URL ahead of time, it's go.sevensignal.com/VUG. I mentioned we've got an incentive for customers to come and join. We will be paying for their lunch. It's going to run from 11 in the morning until 1 in the afternoon. So you'll get a nice DoorDash gift card for joining us if you're a customer. Got to treat our customers special over here. Lead Badman is going to keynote for us during that session, so please join us. We're excited about that. We're going to have customer presentations. You're going to hear about the product roadmap as well. And that webinar is also CWNP certified. And if you do join, that's good for 2 credits because that's a 2-hour webinar. So I mentioned our 50 for 50 already. That's the URL. I'm going to drop it into the chat. If you're interested in getting Mobileye free for 50 days, go to go.sevensignal.com/50 for 50. So enough of that. Let's get into the meat and potatoes here. A little bit about Seven Signal, and then I'm going to hand the controls over to Mr. Halles. Seven Signal's been around since 2007. We started the company back in Helsinki, Finland. Moved to the States about 3 years after that, and we've hit a lot of major milestones in that time. We now crunch over 1 billion data points on a daily basis. So we're tracking a lot of KPIs, not only with wireless networks, but also on devices. And we'll talk briefly about that today, but won't go into too much detail. We've got over 200 customers around the world, over 30 partners, a lot of whom are on today. I see their names popping into the attendees. The product, our sensors homologated in over 40 countries around the world. We're completely GDPR compliant, which is relevant to our customers and prospects in the EU and UK. And we've got over 14 patents. So that's important because what you see at Seven Signal, you're only going to see from us. We really differentiate when it comes to products and services. So Seven Signal is here to enhance the digital experience of your end users. And we do that a lot of different ways, but we've built 2 products, Sapphire Eye and Mobileye, that give full visibility into that end user experience and all of the connectivity issues that they're experiencing, getting you to root cause of those problems. Completely AP and device agnostic, replete with reporting, analytics, and alerts, as you would expect. And what we're looking for are what we call the top 7 Wi-Fi problems. Everything in the world of Wi-Fi and connectivity has to bubble up to one of these 7 problems that we find. And of course, they present themselves differently. Sometimes it just shows as slow connection speeds for that end user, or perhaps they can't get on at all. But regardless of how it presents itself, one of these issues are to blame. And what we do is we use our products to run active and passive tests on the network and on the devices for things like packet loss, latency, jitter, MOS score, running a spectrum analysis. So we can get to the exact root cause that your users are experiencing. So they can get on with their day, stay productive. If you're in an environment where in a hospital environment, keeping that electronic health record connected, or your scanners and pickers in other environments, really, really important. So what makes Seven Signal special is that we monitor the network from the outside in versus the inside out, which is what your vendors do, which is great. And we complement all of your existing vendors. So if you look at an existing LAN in the infrastructure, which is on the right there, you all have, if you're not a Seven Signal customer, you're dependent on your vendor tools to give you insight into top talkers and applications and things like that. But where Seven Signal comes in, we're monitoring the network from the outside in, from that end user perspective. In Mobileye's case, we're on those devices, on your pickers and scanners, on your laptops, on your workstations on wheels, monitoring that user experience. What's happening on those devices? Are your users able to connect? And if they can't, why? So real differentiation with Mobileye. And then also our sensors are monitoring the air, the RF for visibility, for service level quality in an independent fashion. Again, we're AP and device agnostic. So just a quick snapshot here of the 2 products side by side. Mobileye, again, is that application that runs on the background of the device, any Windows, Mac OS, Android, or mini PC, looking for these 5 problems: adapter driver combinations, roaming, adjacent co-channel interference, coverage, and congestion. And Sapphire Eye is, again, our perfect client or sensor that lives up in the rafters with the access points, looking for network services, wireless LAN configuration, interference, unlike any other. We're the only vendor in the entire industry to have this complete suite that we can offer to you. So thanks for listening to that pitch. And Dave, I'm going to hand the controls over to you so we can start going.
Sounds great.
And if you haven't taken a moment to let us know where you're logging in from and whether you're working from home or not, please do that. I'd love to share that with the group while Dave is getting pulled up here. So it looks like we've got a couple more folks coming in. We got Texas, we've got Alabama, Arizona, Seattle. Welcome to our partners up there. So a lot of familiar names on here. Thanks for joining us today, folks. Dave, the floor is yours. Tell us a little bit about yourself, if you don't mind.
Sure. Hopefully you do see my screen right now, Don.
I do.
Cool. Okay. I'm a solutions engineer here at Seven Signal, CWNA certified. A lot of experience with wireless, over 25 years in product development and industry standards. One of the places I was at was at Cisco Systems, and I was recognized as a Cisco innovator. As Don mentioned, we're in Independence, Ohio, and just south of us is Richfield, is where the Aeronet team was at. I had chaired some of the IEEE 802.11 task groups, for instance, 802.11i, which you might be familiar with when you see WPA and WPA2. And then more recently, I was the initial task group chair for 802.11ah. 802.11h has not really made it big time, but I find it very interesting, and that it also it put in some of the mechanisms that were kind of incorporated into 802.11ax. So you might see some of that there. I was also involved with the formation of the Wi-Fi Alliance. Used to be called WECA back then. And then I got a number of patents. I lost track when we got up to 13. So how many that I actually have. So that's enough about me. Gonna move on to.
I can never get enough of that, Dave. You could keep.
Okay. Channel utilization. What exactly is it, and why do I care? Right. That's what we really want to know. So what is it? Why do I care? So what is it? It's the amount of activity that's kind of going on in the wireless LAN. And it can include not just the Wi-Fi traffic, but any nearby Wi-Fi traffic. For instance, your neighbor. If you're a corporation and you've got, you're in a building and you've got some people below you, obviously they got their wireless LAN and they're not coordinating with you, then obviously that could run into some issues. And it could also be things like other types of technology, for instance, Bluetooth or Zigbee. So why do you care? Well, the reason why you care is because as that channel utilization goes up, your performance is going to drop. So that's why you care. So you can kind of think about this as the traffic on the highway. Everybody's experienced this, right? You're on the highway, it's like really crowded, and what happens to your speed? It goes like way down. It's the same thing. If you got a ton of people, as people come into the office, start using the wireless LAN, if they start doing something, a large amount of traffic, for instance, some backup over wireless, you're going to see your performance really start to drop. So you kind of like, it's like sometimes this is not always obvious. It's like, you mean you're telling me that as I use it, because right when I start to use it and I need it, that my performance is going to go down? Yeah, that's the way it goes. That wireless is a shared medium. The good news, though, just give it a little bit of a Seven Signal pitch, is that Seven Signal customers are able to know the details about that channel utilization. They're able to manage that. You kind of think of this as you've probably seen these signs on the highway. You're going along and the sign kind of tells you, well, it's going to take you this long if you go this way and this long if it goes another way. And really what they're doing, they're kind of looking at the utilization of the highway, how many people are on that highway, and how long it's going to take you to get. And now you might have an alternate route, and you can kind of get there quicker. So it's kind of like the same thing that we're looking at with wireless LANs. Here we're kind of also kind of showing it as you kind of put together like throughput and channel utilization. When you're going off and you're taking a look at the throughput, you're typically in the middle of the night, nobody's in the office, you'll see that the throughput goes way up and the channel utilization goes way down. This is another thing that kind of bring up is that people that are not customers of Southern Signal, they kind of say, well, I'll go in there in the middle of the night because they don't want to bother people, and they'll run their tests. If you run tests and you've got problems in the middle of the night, you really got some problems. And then when people should start showing up, that you're really going to have problems. So it's kind of like telling you, it's kind of like in the best scenario how things are working. Really, what you want to know is when people are in the office and running, how is their performance going? We do have trying to give you a sense of the Southern Signal visibility when we get into not just the sensors and kind of going what we call eyes, and then kind of giving channel utilization. We bring some of the same information into Mobileye, and we're kind of doing showing that information here. I know Don said that no commercials, but I did get a peek on the next release, which is coming up for Mobileye. There's some cool stuff there. so if you get a chance, if you're a Mobileye customer, I'm giving up some super secret stuff, that there's a release coming out and it's going to have some cool stuff here.
That's allowed, Dave. You can do that.
Okay. And it'll be much cooler than this graph. This graph is just kind of showing you that the same thing on Mobileye, where you could kind of end up, we'll give you some information about, well, is it co-channel interference? Is it adjacent channel interference? And then you can kind of get into it and find out some more information about that to figure, and this all relates to channel utilization. Well, why is there the utilization so high? Here you're able to kind of dig into it, and you could kind of see, oh, somebody went crazy with the SSIDs there. That was actually me, by the way, but I was doing some testing. So that's, this would not be a good idea to run that many SSIDs on the same channel. Somebody overdid it. Yeah, that was me. Sometimes we run into this, that customers or people would just generally say, well, 2.4 is garbage, blah, blah, blah. What you could do about it? Wham, wham, boo-hoo. I'm going to stick my head in the sand. Don't stick your head in the sand. There's plenty that you could do about it if you know details about what's going on. And that's basically what Southern Signal does. Is it kind of gives you that information so you can say, oh, this is what's going on. I'll adjust to get around it, or at least minimize it. So let's dive into channel utilization. What exactly is channel utilization? If you hear the term channel utilization and you start to get worried that that's too technical, don't worry about it. An analogy is when we're talking about when we say a channel, you can think about it like with a TV broadcast. Well, you could say go to channel 3. When you say channel 3, well, what does that mean? That's kind of like saying, well, tune to 63 megahertz with a 6 megahertz wide bandwidth. That's kind of like a mouthful. So it's a lot easier just to say, well, go to channel 3. That's the same thing that Wi-Fi does. If it's on 2.4, you might say go to channel 1, 6, or 11. Likewise, you say the different channels on 5 gigahertz or 6 gigahertz. It's a lot easier than trying to specify the frequency and the channel bandwidth and so forth. Primary locations for Wi-Fi channels. I'm also kind of trying to bring up the differences here between 2.4 and 5 gigahertz. I didn't bring up 6 gigahertz in here, but that's also kind of interesting as well. I do refer to it a little bit later on, that if you're looking at the channel utilization strictly on 2.4 versus 5 gigahertz, you're going to see that 2.4 is typically going to be much higher than 5 gigahertz. And there's some reasons for that. And that's kind of like in the table up above. One of the big things that we talk about is non-overlapping channels. Well, in 2.4, there's only 3. 5 gigahertz, there's 25 if you just use 20 megahertz wide channels. Likewise, if you'd extend that to 6 gigahertz, that you'd see, oh, you know what, there's a ton more room. So therefore, that's one way of kind of allowing more, bringing that channel utilization down. Lowest data rate is also related to this. It's with a lower data rate, it takes longer on air to transmit the same data. And since some of these are drastically different, you think about it, 1 megabits per second versus 300 megabits per second. Obviously, that's vastly different. It's going to be on the air, a lot longer if you're just transmitting at 1 megabit per second. And then, all things being equal, if you were to transmit on 2.4 versus 5 gigahertz, you're going to go much farther on 2.4 than on 5 gigahertz. And then likewise, that there's other devices we were talking about, like Zigbee, Bluetooth, and so forth, and then baby monitors. There's a higher chance of you having interference for some other type of device on 2.4 than 5 gigahertz. So all of those types adding up together, you're going to see that on 2.4 you're going to have a higher channel utilization generally. We talked about that the 3 non-overlapping channels on 2.4, and then likewise, why is that an impact? If sometimes people get confused because they're thinking about it being at home. When they're saying, well, at home, the implications are I have 1, 2 access points. So it's not that big of a deal. If I got 3 non-overlapping channels, I got 2, I got 1 to spare. But if you're in an office, now I've got a ton of access points that are deployed, right? And so therefore now it's very difficult, and I'm showing these colors to the chart on the left, where it's saying, well, it's very difficult to have it so that these are not overlapping, that you're using the same channel in the same area. It's going to be impossible. If you go to 5 gigahertz though, with 20 megahertz wide channels, then you kind of see the chart on the right. So it's very easy to make it so that you're not running on the same channel right next to each other. This is kind of the same thing that I was talking about. And the other thing that I kind of mentioned is that the wireless is a shared medium. If you think for people that are old enough and they used to think about hubs instead of switches, it's a shared medium on the wire, whereas switches, they kind of segment that all off. Another thing that could happen to increase the channel utilization is just poor channel planning. And that's what we're kind of showing here is that, say for instance, that somebody, you kind of like went, I like channel 1, you kind of like deployed it, or maybe something like RM or ARM went off and kind of went crazy and decided to put everybody on channel 1 except for a couple of access points. Well, then obviously, then you're going to see that on channel 1 that channel utilization is much higher. And then this is basically what we're doing is we do have a report to kind of show you that happening, to say, oh, you know what, and then this is a lot of times with wireless, and I'm sure you kind of you've seen this. Somebody might say that they're having a problem and they're on wireless. Somebody right next to them might be on wireless as well, and that they are having a problem. Really difficult to understand. It's like, well, which access point are you on and what channel are you on? Well, here, if you're on the one that's on channel 1 and that's very heavily used, then your experience is going to be drastically different. So therefore, you'd want to know that. So the poor channel planning, that the analogy that I use is that on the highway, say for instance, you got this multi-lane highway, should be able to accommodate a lot of traffic, but if everybody was in the high-speed lane, it's like, well, that's not really a good idea. You might want to spread out there a little bit, be able to go a little bit faster. Channel widths also lie into this. When I talked about on 5 gigahertz that there are like 25 non-overlapping channels, that's with 20 megahertz. Now, if you double it to 40, obviously you're going to have less. If you use 80 and 160, obviously you're going to have less and less channels. 802.11n introduced the notion of 40 megahertz wide channels. And then likewise, that since that was such a great thing, people said, well, 40 megahertz is great, 80 is going to be even better. and then 160 is even greater. There are some side effects to that. If you're at home, it's probably not that big of a deal because you're just one access point. But if you're in a carpeted office, then that's going to be an issue. So when we talk about 2.4, here I'm kind of showing the different channels and channel widths. This is where we're kind of say, look, if you're running with 40 megahertz wide channels, it's kind of easy to see that you're going to you're overlapping with you're overlapping with channel 1 and 6. So therefore, we kind of say that's not really a good idea. Now you might say that, well, what about, I heard about this Wi-Fi 6, 802.11ax, and that you kind of run 40 megahertz there. There, I would still say you may want to hold off on, still run just like 20 megahertz wide channels. There'd be a lot that I think that would be a big long discussion on it on its own. One way when I think about it is, well, if you did introduce a Wi-Fi 6 on 2.4, are all your access points running that? Are all your clients running that? Probably not. So therefore, it might not be such a great idea. Channel widths. Here, you know, this guy probably thought it was a good idea that it's like, hey, let's just make it wider. I make less trips. Maybe for him it's a good idea, but the guy that's behind it, it's like, well, maybe I don't want to follow so close. It might not be such a good idea. Channel selection also, like when we talked about it, this is especially true on 2.4 that we kind of talk about. There's 1, 6, and 11 that are not overlapping. You want to avoid those channels that are in between there, because you're not only impacting one, but you're impacting like a couple channels. If you're driving along, and you might have seen this as well, and if you saw this, you know, you might be using some expletives. I'll leave that out. There might be some children out there, so you might be saying something like, "Hey, pick a lane, buddy," so that everybody will calm down a little bit. This is giving an idea of the number of channels that we're talking about, and I had talked about 80 and 160 megahertz wide channels. The thing that now this is on 5 gigahertz strictly, and the thing that they're kind of showing here is if you were using 160 megahertz wide channels in 5 gigahertz, you're taking yourself into the direction of 2.4, where we talked about 2.4. It's like it's only got 3 non-overlapping channels. Here, there's only 2. And if you say, well, I've got DFS, you got like none. So really, if you want to go with the larger channels, there's a great opportunity. We already had a webinar talking about it, and that's to go to 6 gigahertz with Wi-Fi 6E. In that if you're running with 160 megahertz wide channels or 80 megahertz wide channels, you really want to think about that in the 5 gigahertz space, because that's going to increase your channel utilization. We also kind of give you an idea from our reporting as to what channel widths are being used. So it's kind of easy to figure out, oh, this is so the one that's in the middle, that it's kind of easy to see that, oh, that's not a big deal because there's nothing there. But the one on the right, it's actually, there's a number of other access points that are operating there, and that they're going to be causing that channel utilization to go up. So let's talk a little bit more about the details about channel utilization. We talked about, you know, channel planning and so forth, but what about the traffic itself that kind of goes on? There's a lot of different things that are going to be transmitted, and I'm trying to show that whether that's the Wi-Fi traffic itself. There's the data traffic, which I'm kind of showing there in blue. You want to maximize that. That's the good stuff. And then there's management traffic. Just like at work, you hate to have too much management. It's good to have some strong management, you know, that's great, but you don't want to have a bunch of management taking up and using up all the resources. And here, what you end up seeing is that that can happen, and that by using 7 Signal to kind of see the details of it, you could now start to minimize it. And one of the things I kind of wanted to show here is to kind of, we end up breaking up the traffic into different types of categories. For instance, what about the beacons? What about the other management type of traffic? What about the data traffic itself? And once you're able to kind of see that, you're able to say, oh, you know what, I can see that by reporting the different types of traffic. Here I can kind of see that 85% of the traffic, that's actually just being used by the beacons coming out. So, you know, sometimes people don't realize it. It's like, oh, I got all these people. They think, oh, because I've got all these people on it, that's why the Wi-Fi doesn't work. And it's really, well, you've kind of overloaded with the number of access points. They're all sending out these beacons. Well, that's going to go off and make your channel utilization go up. And therefore, as people start to use it, it's like, you know, really, that's what you really need to reduce, is that overhead. So what affects what if you could kind of make those beacons coming out less often? This is actually something that, you know, you kind of set up and configure. Typically by default, that they come out like 10 times a second, the beacons, and you could adjust that so that it's kind of coming out like maybe every 3 times a second, roughly. Then also that what ends up causing the channel utilization to go up is, I was talking about the data rates. And if you are, those beacons go out at the lowest data rate, the mandatory data rate. So for instance, if you said, well, I've got these 1 megabit devices out there, or maybe you don't have those 1 megabit devices, and well, the beacon itself is going to go out at that very low data rate. Here you kind of see it becomes wider. It takes longer to transmit. You don't want it to be wide and long. You want it to be narrow and quick, get off the air. So therefore, if you're able to kind of make that data rate quicker, higher, that the amount of time that's going to go on is going to go lower, and your channel utilization is going to go down. The other thing that can make your channel utilization go up is the number of SSIDs that you support. It's very useful to have multiple SSIDs. For instance, typically that's people will have like a corporate network and then a guest network. So it's kind of like 2, not a big deal. Sometimes that there'll be some kind of specialty SSID. Okay, 3. Still not too bad. But as you start to use more and more SSIDs, what's actually happening? Well, you're sending out multiple SSIDs. If you supported like the corporate and a guest network, in reality, what's happening is on the same channel, you're sending out 2 beacons. That's causing your channel utilization to basically double. So when it comes to the beacons, so obviously that's not good. You want to try to reduce that. And if you've gone crazy where you've said, well, I've got 9, 12 SSIDs, you'd see that by reducing that, by collapsing some of those SSIDs, that you'd have a dramatic impact as far as the airtime utilization, and therefore your performance. And a big, I talked about kind of typically going out at 10 times per second. And if you said, well, instead of them kind of going out at 10 times per second, if you were to make it so that they kind of go out less frequently, it'll make it so that the channel utilization will go down. By doing these number of things, you can kind of see that on 2.4 that things will drastically improve your performance. You can see that here we're making some changes, and then you got a 80% reduction in overhead. So what does that relate to? You know, obviously people might not really care about the overhead, but what about their user experience? Well, the throughput goes up by 23%. You can see their connection stability. This is where people really care is, you know, I've connected and you kind of see your connection going in and out. People hate that. Trust me on this one. You really want to see a strong connection. And so therefore, by reducing that overhead, you're making that connection more stable. And therefore that the user experience is greatly improved. So what all are we doing? Removing support for older devices, you know, that are transmitting at like 1 megabit per second. We're reducing the number of SSIDs, and then we're extending the beacon period. Those 3 things there, if, you know, sometimes you might say, well, I can only do 2 of those. There's 3 things that you can kind of go off and do, and you'll improve your performance. Typically, this is on 2.4, just because that 2.4 has only got those 3 non-overlapping channels. Another note about beacons. It's like, Dave, you're gonna talk more about beacons? That you might look at one of the reports, you might see that your printer is showing up and you say, well, what the heck is that all about? And there's a feature called Wi-Fi Direct, which is something that the printer starts acting as an access point, basically. And if it's already wired up, you know, via Ethernet, then there's no point to that. And so therefore, you know, and what's happening is that that beacon, like I was saying, is increasing the channel utilization. Turning it off will improve your user experience if you're already wired. So sometimes people will ask me, even though I've got a lot of wireless experience at home, I've got a lot of devices that are wired. Why do I do that at home? My television, it's sitting there. I'm not moving my big screen TV, so there's no point in having it running wireless. I'll run it wired, and therefore that I don't have to worry about that channel utilization increasing. Then when I do use the wireless, that it's better. So is your printer connected via Ethernet? If it is, that you don't really need that, and you can kind of disable that functionality, and therefore increase your usability. Then besides, there's a lot of other management type of traffic besides beacons. There's probe requests and probe responses. This is where you're kind of like trying to roam. The client card is going off and looking for the different access points. And that could also, if you're in a crowded space, You really see this in things like libraries, arenas. You want to take a look and say, you don't want all access points responding to that probe request. You want to put some kind of like additional conditions on why the access point would respond. That the number of the AP manufacturers have features that kind of do this, where they'd say, hey, you know what, if I only receive the probe request with a certain signal strength, therefore I kind of like know that it's close, therefore then respond. But if it's really far away, let some other access point respond to it. That'll reduce the amount of channel utilization based on those probe requests coming out. What else consumes stuff? Yeah, there's other things that are out there. For instance, there could be interference. A lot of people in 2.4 talk about the microwave ovens. And then there could be other types of transmissions. For instance, I talked about Zigbee and Bluetooth. Here we do spectrum analysis on the Sapphire Eye side of things. And it's kind of easy then to kind of pick up and see where things are coming out. If you're looking at these graphs, it's kind of easy then to kind of see, oh, that there's some Zigbee that are kind of coming out, which I kind of pointed to. The spiky things that are coming out 1 megahertz apart, that's Bluetooth. And you're able to kind of then see how much that there's by doing the waterfall report, how much is actually kind of going off. If you now Bluetooth as it's on its own, if you've got like just the phones, it's not a big deal. But there are times where you'd say, oh, you know what, there's a heavy usage of Bluetooth. For instance, if you're a help desk and everybody's wearing these headsets that are running Bluetooth, and it says very crowded, using a lot of Bluetooth, then you might see that in the waterfall report that there's just a lot of Bluetooth traffic that's causing interference. And this is where I start to turn things back over to Don and say, hey, do we got any questions?
Yeah, great. Thanks, Dave. Thanks for that overview of channel utilization. Very helpful. And I've got a couple of messages already about getting a copy of the slides, and we'll be sharing a copy of the recording. The answer is yes to all those questions. We do share these presentations via email, and also we post those to our YouTube channel. So got a couple of questions here, and a couple other folks pinging me about where they're dialing in from: Florida, Switzerland, Southeast PA, Royal Oak, and it looks like most folks are working from home. So first question here is from Michael, and he's talking about consumer access points. He says, don't consumer models typically use a smaller or limited number of 5 gigahertz channels, increasing probability of co-channel interference?
Yeah, what you might be referring to is that the flip side to it is the enterprise side will typically support the Uni 2 channels that where radar detection is required, and consumer grade access points, they might be say, well, we're not going to even bother with that, you know, just run on channels below and above that don't require that. Yes, that would reduce the number of channels on 5 gigahertz, and so therefore that would also cause that the channel utilization go up. Now you might think about it as well as where are these used? If it's used at home, it might not be that big of a deal because you don't have that many of them. But if you are in an office and you're using one of those access points there, then you know, you might want to spend the money. Because now that you've seen the channel utilization slides that kind of tell you why you want to do that, that you'd say, oh, this is why that you'd spend the extra money on one of those enterprise access points.
Dave, you changed the world today with this channel utilization presentation. So thanks for the question, Michael. Thanks for the response, Dave. Question from Miner here. Is 7Signal software or hardware? In case you missed the first part of the presentation, 7Signal is a software company. We're a software as a service company. Now, Mobileye is our agent that installs directly on the devices, and Sapphire Eye is our software-enabled hardware or sensor. But we don't charge for hardware anymore. We're completely software as a service, subscription-based. But thanks for the question, Miner. Ahmed, asking a question about getting a copy of the slides. This will be on demand. It'll be on YouTube, so you can access it there. Can you say a bit more about the potential issues that may be caused by increasing the beacon interval? I always understood that was a bad idea.
Increasing the beacon interval, yeah, that's increasing the beacon interval. If you think back to those slides, basically what it was showing was that by making that the length of time between the beacons going out makes it so that the transmissions go down, so therefore the channel utilization go down. It kind of improves. So it's the converse as it happens. If you start sending those out more frequently, then what you're going to do is you're adding that overhead, and really, you know, if you think about it, that the beacon's going out, that as long as you're not on a channel that's with radar, you're able to use the probe requests and probe responses to figure out if there's a channel, if there's an access point available, which is going to be more of a proactive type of approach. So therefore, it's not you don't really want to send them out very frequently. Another thing that you might be concerned about is that sometimes people will say, "Oh, we don't want to play with that." Because we have some old devices, and by old I mean, you know, like when 802.11 first came out, like basically like around 2000 or something like that. There are some devices, embedded devices, that if you, especially, you know, like on 2.4, that you're saying these are some very old embedded devices from a really long time ago, and they don't really go by the standard. They just kind of are very narrowly fixed, and those devices, because that they're developed, they're not open to that the beacon period changing and make you know, varying. That would be sometimes of a concern. But those are usually kind of some very specific concerns about older devices. If you got some relatively newer devices within the last 5 years or something like that, I would say that that should not be a concern, that they'll be able to handle that.
Mhm. Thanks, Dave. Thanks for the question, John. Michael is responding back in about, he says he's got lots of neighbors using 152. You know, so, and a lot of our engineers now are dealing with a lot of home routers and having challenges there. You know, is there something to be said for mesh networks, Dave? Any thoughts on that and how channel utilization, you know, maybe is optimized by mesh networks? I've got an Eero network at home, and I love that system.
That's actually like a really good question, because uh, with uh, the mesh type of systems, that it kind of depends on that the mesh, the one that's kind of going back, is it using the same channel or is it using a different channel that it's providing access? If it's, I think sometimes it depends on, you might get a lower cost mesh AP by saying, oh, it's going to use the same radio for access as going back. Now the cost of that is obviously if all the traffic going back is on that same channel that you're providing access, you're going to have more channel utilization. So I would spring the money for a more expensive solution with mesh that would have a different radio, so it could be on a different channel. It could be at a different transmit power as well, and therefore, you know, reducing your overall channel utilization.
Thank you, Dave. And thanks for the note, Michael. So we've got time for, I think, one more question here. I'm going to ask David's question. David is from New York City. It says, does DFS channels increase utilization? And what's your recommendation for DFC channels? Dave says he's using 7 Signal in a hospital. So thanks for the question, David. Hope to see you at the virtual users group at the end of the month.
And a great name too.
Yeah.
What radar detection is going to do is it kind of depends on what types of issues that you end up running into. If you're in the area where that there is no radar going on and that there's no radar detection events, and you have some equipment that does not provide a bunch of false radar detects, then you might say, well, things are going great. But either of those are going to cause some severe disruptions to you. What ends up happening is when the access point, it's called like the master, that if he kind of goes off and detects that there's some radar, it's got to get off the channel. And so therefore, if there's false detects, then you're going to end up seeing that they're going to have to, get off of those channels, go onto the channel that, that after a while, if you start picking up on all of the uh, uh, Uni 2 type channels, then you'd end up saying, oh, the only place I got to go are some limited set of channels. Obviously, those channels are going to start to go up in channel utilization. So therefore, that's one of the other advantages of, if you're aware of, like you sat in on some of the Wi-Fi 6E webinar that we did, when we were talking about 6 gigahertz, that the approach is completely different there, that there's a reporting mechanism to kind of go back instead of trying to detect that there's something there. And that avoids the whole false detect type of problem.
All right. Well, thanks for that response, David. I hope that helps. Ladies and gentlemen, that's going to be all for today. I know there's other questions coming in. We're happy to answer those offline and get those addressed for you. Thank you very much for joining us today. We'll see you all next week. Enjoy the rest of the weekend. Thanks, everybody.
Bye, everybody.